Okay, so for the second video of this morning, we are going to look at isotopes. Something I want you to remember is that it's the neutrons that make the isotopes. Everything else is the same. Iso at the front of a word means the same. So I'm going to introduce the revolutionary new way of explaining this using the isodog. This is a heavy isodog. It's an ugly dog. And this down here is a light isodog. And what you will notice from the two isodogs is that they both have four legs, they both have fur, they both wag their tail, and they both go woof. So all of those dogs are exactly the same, except for that dog over there is a heavy dog and that dog down there is a light dog. Okay, as if that wasn't enough, can I introduce to you the isocat? This is a heavy isocat, and that's a light isocat. Ridiculous, I do apologise. And both cats have four legs, furry ears, a wavy tail, and both cats go meow. There's no difference between these two cats apart from that is a heavy cat and the one down there is a light cat. Okay, that's enough of the silly. Let's talk about atoms. The isotope. We're going to use a carbon isotope. This is a heavy carbon isotope, and that is a light carbon isotope. And just like the silly things that came before it, both atoms have 6 protons and 6 electrons, and by all means pause the video and count them. And both of these atoms do the same chemical reactions. So both of these atoms, for example, would burn in air to form carbon dioxide. However, if we now just look at the heavy isotope of carbon, we can show it like this. The total number of particles, and you can count them, is 14. However, only 6 of these are the protons. So if we take 6 away from 14, we get 8. So there are 8 neutrons in the heavy isotope of carbon. Okay, if we now have a look at the light isotope of carbon and do exactly the same, you can count that there are 12 particles in the nucleus altogether, and only 6 of those particles are protons. So we take the proton number away from the mass number and we get 6. So what makes one heavy and one light is that one has 8 neutrons and the other one has 6. Okay. That is why we call the heavy isotope of carbon carbon 14, because that total mass is 14, and the lighter version we call it carbon 12 because the mass number is 12. So for the rest of this video I'm going to use the same way of describing isotopes. Okay, hooray for neutrons, because although they have no charge and although they don't have anything to do with chemical reactions, all of that happens in the electrons, it's the neutrons that give additional mass to the atom. And those of you that did some of the extension work on Tuesday, I think, will also know that the neutrons help to keep the nucleus stable and stop it from breaking apart radioactively. Over to you now. What you are going to need is a bit of paper, and you can write out some answers to these questions as you go and pause the video while you do. Okay, there are 2 isotopes of boron, boron 10 and boron 11. Here are 3 questions. How many protons in these isotopes? How do you know the answer to that? And how many neutrons are there in boron 10 and boron 11? Click the pause button and write your answers down now. Okay, so grab a green pen. How many protons in these two isotopes? Well, there are 5 protons, and how I know is because this is the proton number. Now let's do some maths. How many neutrons in boron 10 and boron 11? Well, for boron 10, we take 10 minus 5, mass number, take away proton number, and we have 5 neutrons in boron 10. And for this one over here, boron 11, we take 5 away from 11, and we have 6 neutrons in boron 11. Okay, next question. There are 3 isotopes of silicon, silicon 28, 29, and silicon 30. And here are 2 questions. Apart from the symbol Si, what else here tells you that all 3 of these are the same element? And the second question is, how many neutrons in silicon 28, 29, and silicon 30? Pause your video and write down your answers. Okay, get your green pen and let's mark your answers. Apart from the symbol Si, what else tells us that all 3 are the same element? It's that proton number again. The proton number tells you what element it is. If you had more protons, it would be a different element altogether. How many neutrons in silicon 28, 29, and silicon 30? Okay, let's do the sums. 28 minus 14 equals 14. How many neutrons in silicon 29? We subtract 14 from 29 and we get 15. There are 15 neutrons in silicon 29. And last of all, silicon 30, we take 14 away from 30 and we get 16. How did you do? Okay, how did you get on? What I'd like you to do now is practice some of the things that we've learnt today on the worksheet that you can download in Google Classrooms. There are 3 isotopes of oxygen. There they are, 16, 17 and 18. Here are the questions. How many electrons, negatively charged electrons, in all of these isotopes? How do you know that answer's correct? And how many neutrons in oxygen 16, 17 and 18? Pause your video now. Okay, let's go through the answers. Get your green pen out. How many electrons in all of these 3 isotopes? 8. Because whatever the proton number is, there's an equal number of electrons because the positive charges and the negative charges cancel each other out. That's how I know. And question 3, how many neutrons in oxygen 16, 17 and oxygen 18? The first one is mass number, total number of particles in the nucleus, take away just the protons, and that gives us 8. Second one, the mass number, particles in the nucleus, take away 8 protons, gives us 9. And for the last one, it's 18 minus 8, gives you 10 neutrons in oxygen 10.
18.